Hi everyone, let's continue with today Leetcode problem. So today we are going to solve Leetcode problem number 347, that is top k frequent elements. So let's go through the problem statement first. So given an integer array nums and an integer k, we need to return the most frequent elements, k most frequent elements, and we can return the answer in any order. For example, let's try to understand this problem statement using the example that is provided to us. So here you can see like we have one array that is given to us and an integer k, and within this array we need to return the k most frequent elements. Okay, so here k is 2, so we are going to return two most frequent elements. So how we are going to calculate this frequent element? So definitely like for each of the elements we would need to count the frequency. So for example, here 1 is existing twice, not thrice. 2 is existing twice, and 3 is existing only one time. So what we could do, we could return the most frequent element, first two most frequent element, that is 1 and 2. That's why the output is 1 and 2. Okay, hope you understand this example. So for the second example, we just have one element and we have k equals to 1. Okay, so we are going to return 1. If for example, let's say like k equals to 2, then in that case also we should just return 1 because we don't have any other element. Okay, so hope you understand the problem statement. Let's try to come up with some approach to solve this problem efficiently. So here, so the one way to solve this problem is using sorting. Okay, let's try to understand how can we utilize the sorting technique and what are the limitations of the sorting technique. Okay, so if we perform the sorting, then we would get the sorted data. Okay, that I'm currently representing here. And after that, what we could do, we could start iterating this array and can start counting the frequency. Okay, so for one, I will count the frequency, and let's say like I'm storing it in map, and for 2 I would count the frequency and I would store it in map, and for 3 also I would count the frequency and I would store it in map. Okay, but this way to calculate the frequency, the way we are performing the sorting is not an optimal one. So instead of performing sorting to calculate the frequency, we could do hashing directly. And for implementing this hashing technique, what we can do, we can use directly use the map. So in map, like we could use the hash map implementation. So here, like for each of the elements, first I will check whether the elements are present or not. If it is not present, it's by default frequency is 0. Okay, and if it is present, I will just go ahead and fetch the current value and accordingly update it. So for a one initially it is not present, so it would return me 0, and after that I added this element, so I kept the frequency as 1. Again for the second element, so it's not always necessary like data would be sorted. Let's say like I have some random data 1 2 1 2 and 3, something like this. So the next element for 2 also, like the this element is not present, so by default we'll get the frequency as 0. I'm just going to insert this element and I kept the frequency as 1. Now I'm going to process the next element, that is 1. I will check in my map whether this element exists or not. If it is existing, what is the frequency? So I see here the frequency is 1. I will just increment its frequency by 1 because now I have two instances of 1. Let's continue and process the remaining element. For 2 also, like I will fetch its current value, that is 1, and I will increment its value by 1. And for 3, I will just go ahead and insert. So now we have our map ready. Okay, there we are having key and value. Okay, and in this map, like a default ordering, what we could do, since we are using hash map, so there would be no ordering of the element. So it could be like first we have this 2, then we could have this 1, and then we could have 3. Okay, something like this. And while returning, we need to perform the sorting on the basis of this value, and accordingly we need to return the key. Okay, so let's say like this is the sorted data that we could have, and after that we can start returning to 1. And if I return 1 2, there is no issue. That is clearly mentioned in the problem statement. Okay, so we understand one thing here, like to calculate the frequency of each of the element, we should not use sorting because it would take n log n, and still we would require extra space to store this information. Okay, So the space complexity is order of n. So instead of using sorting, we could go ahead and use hashing. The time complexity to perform the hashing operation would be order of n, and space complexity would be order of n. Okay. In worst case, what could be the scenario? Like all elements are distinct. So in my map, I would have something like this. Okay. So we just discussed the way to calculate the frequency. Okay. So the step one was calculate the frequency of each of the element. Calculate the frequency of each of the element that we have decided to go ahead and do hashing. Okay. Now, second step is somehow we need to persist this information in such a fashion so that at any point of time I can provide k and I would get the result. For example, let's say like uh, it is in my map, and in the map itself I perform the sorting and return first k element. That we can also do. Okay. So then in such cases, what could be the time complexity? So we need to perform the sorting on map, and in map the max number of element in worst case scenario could be order of n. So the time complexity would become order of n log n. Okay. And after that, at any point of time, if someone is asking for k, I would go ahead and fetch the first k element, and I can simply return that one. Okay. So this solution would work, and the final time complexity for hashing the time complexity would be order of n. So overall time complexity would be order of n log n, and the space complexity would be order of n. So this is a working solution. It would definitely work. But let's say like I have a use cases, so I'm just trying to cover one more concept so that we can extend this approach to solve this problem as well as some other type of problem. Okay. So here if you see like we have a static nature of data that is provided to us. So this is not changing. But what could happen if these data are continuously changing? Let's say like someone is adding some data into this one. Okay. Some more data. Some streams of data is coming. Okay. And someone is updating this data. Okay. Then this k element, top k element will not be static in nature. If our data is changing, then definitely like this top k element would also get changed. So if we apply the same logic here, like doing hashing and after that sorting, sort the map, then what could happen? Let's say like for this state of data, I perform the things and I just return the result. And let's say like few more elements got introduced, like 4, 5, 6, then definitely the entire result set has got changed. So again, like I need to do the hashing for these new elements that I will definitely do. But now again, I need to sort the entire array or entire map. Then for each query, get k element. First, I need to do sort, then result, return result. So if you see the challenges here, like for each k, like what we are doing, we are first sorting, so that would take n log n plus k. So this would become this k top k element would all time like have a time complexity of n log n plus k, that is n log n. So instead of this, like we could use some heap data structure, and where here we have a use cases of getting the top k element. Okay, so what we could do, we could use max heap. So what would be the benefit of using max heap here? So at any point of time, if new data are getting inserted to this max heap one, this max heap internally will take care of heapifying to itself, and at any point of time, you just need to fetch the top k element. That would be sufficient. Okay, so your get operation time complexity would be k log n. Okay, where n is the total number of node that is present in this heap, and you are performing k poll operation, basically fetching top k element. Okay, and the top one always contain the max element, so the overall time complexity would be k log n. So if you see here and compare it with the sorting technique, so from n log n we have reduced the time complexity to k log n, so that is more optimal. So if we use the max heap implementation, then we can easily solve the current problem, and as well as we are able to take care of the scenario when we are adding or updating our given input. Okay, so that would work in both cases. So let's try to implement the solution quickly. So first we need to perform, like, it has two things that we need to take care: hashing to get the frequency of each element. Let's do that. Okay, so we have integer, let's say, like, I'm calling it hash map, and now I will simply go ahead and iterate this element. Basically this element I simply means iterate the array and try to update our hash map. Okay, so I'm calling this get or default method, so that if the element are not present in that map, instead of returning null, it should return me the default value, that is 0. Okay, so in this way, like, we have performed the hashing. Now what we have to do, we have to perform the sorting. So for performing the sorting, either we could go ahead and perform the actual sorting on this map, or we could use some data structure like priority queue, and there we could have our own implementation of the sorting logic, and that could easily work for this current element, and as well as the cases like where we are receiving instead of the static data, streams of data, that would work. So let's try to implement this priority queue. Priority queue, we would need of pair type, okay, because we need key and value, so then only, like, we could take care of, we could take a call. So let's say, like, on the basis of value, we are doing the sorting. Okay, let me define this class pair. I'm just encapsulating the two attributes. One, let me call it key, and the second one, let me call it value. I'm just providing one constructor here to properly create an object of this pair class and initialize the variables that is present. That is this key and value. Okay, now we have this proper pair class defined. We are using this class one, and we have our own comparator written. There we are sorting it on the basis of this value. Okay, and we are sorting it in decreasing way. First top one, and after that the smaller one. Now let's try to insert this. Okay. Now we have inserted this element also in our priority queue. Now we just need to return the result. So let me create a result array of size k, and as soon as, like, we have while our priority queue is not empty and k minus minus is greater than 0, we should continue to the polling. Okay, and what we could do, let me create an index here. So from index 0, I will go ahead and start inserting the element into this. See, do we have any other issue? No, we don't have any other issues. I'm just fetching the key and inserting it. Okay, let's try to understand. So here we would have, okay, dot key, because we have not created the getter method. I can directly access. Okay, it should not be a method. It's just a variable. I'm just directly accessing this key because the scope of here this key that you can see here is default, so it would allow me to directly access this key. Otherwise, we should have our own getter method for this key. Here you can see like it is getting, it is working as expected. Let's try to run for some of the custom inputs. Let's run it. Okay, k could expected k to have value from 1 to 1 only. Okay, the answer is not unique. Okay, so maybe like it is guaranteed like the answer is all time unique. It is guaranteed that the answer is unique. So let me try to ensure that one also. So what could happen here? Here the answer should be unique for each of the test case. Why it is showing that one? So for this 1, 2, 3, and here 1, 2 we could return. For 1, 1 we could return. Okay, let's do one thing. Let's remove this custom input and let's run on the given input. And let's try to see. Okay, it is working. So hope it would work for all the test cases. Let's try to run the code. So it is working for all the test cases. Okay. So yeah, that's all I have from my end.